Okay, hi everybody. At least everybody who's here right now. One, two, three, four, five. One, two, three, four. That I just lost somebody who was just here. Anyway, so today uh is Monday. It's the second to last of the actual new material days. So that tomorrow is the last of them. Wednesday, optionally, you can come into class. Otherwise, I'm going to do a Zoom from the classroom if I'm able to. But Wednesday is just a review day because Thursday, of course, is the final exam. You should bring a calculator to the final, scientific calculator. I mean, I have this TI 84, which is a really good calculator because sometimes you have to do expressions, with square roots and cube roots and things and parentheses, and it'll be useful to have a calculator. Of course, you can't use a calculator on a phone during the final. It has to be, a standalone calculator. So that's what's happening. And today, I have a Desmos link here. It's also there's also a link to it in the Google Classroom. Oh, there is, except I didn't click. So now there's a link to it in the Google Classroom, but the code's over here, J2RE37.
Professor, I wanted to ask a question. It has to be a scientific calculator?
What other kinds are when we say scientific calculator? No, it does, because scientific calculator means it has like trigonometry and stuff. So, but a calculator that you can do like square roots on. So
I have one like that.
yeah, as long as you can do square roots on it, you'll be okay.
All right.
So
All right,
like
thank you.
the smallest calculator is what's called a four function calculator that doesn't do square roots. But so you don't need any trigonometry, but being able to cube root things. Sorry, square root is square roots needed. Okay, now okay, let's see where we are. So today's lesson is going to span. So we spent all this time on the Greeks, days and days, and we're still actually on the Greeks because Ptolemy is Greek. But most of the Greek that we were doing was from 500 BC to 200 BC with Archimedes. But then we jumped ahead a couple of hundred years, last class period, to Ptolemy to get his table of chords. So Ptolemy was in the year 100. We did the book that he wrote, the astronomy book, is very famous. And he didn't call it this, but it was eventually translated into Arabic and called the Almagest, which I think means like the great work or something like that. And it really was a great work because it was used as the astronomy Bible from 100 AD all the way up until the 1500s. So for 1,400 years, that book. Part of that book involved the table of chords. And remember, the table of chords was a table that told you for any angle, let's say 40 degrees or 50 degrees, it would say chord, which we usually it's CRD, which is short for chord. When they say chord 50 equals 0.8452, they're saying that they somehow figured out that if you make a circle with radius 1 and you were to make this sort of isosceles triangle, this this line segment, that's called a chord. A chord in a circle is a line segment that joins 2 points on the circle. So saying that chord 50 is 0.8452 means that that's the length of that chord. And that's useful if I'm trying to answer questions like, What if I have some other isosceles triangle, but the radius is not 1? And what if I even have a right triangle? What angle? This chord 50 would be useful for, and you could type it into the chat. This chord 50 would be useful for what angle that's not 50 in this right triangle as far as solving. And oh, let me find my chat. This chat's always very elusive. So with chord 50, told, but which one specifically? If all I have is chord 50, there's not many questions I could answer. What would the chord that has the arrow pointing to it have to be so that I could use the chord 50 value as in figuring out the length of that missing side? Let me call that missing side y so that it's not confused. So here's a 20, a hypotenuse of 20. I have a hypotenuse of 20. And I don't know how big this y value is. What chord would need to be here? Again, we're not solving for it. I'm asking you, what would I need to tell you so that you would then, what would that angle have to be so that it would be possible to answer the y value? Or maybe I should say it this way. If I take the isosceles triangle with 50, 1, 1 are the two legs, and 0.8452 is the base of that isosceles triangle, and I split it down the middle, I will get two right triangles. And what will these angles up here be?
100.
Well, 50 is actually, so 50 is was the original angle. So it's going to be smaller than 50. My original triangle was this. Here okay, yes, it is 20, it would be 25. By the way, this wasn't solving for something. This was just saying like, what sort of question could I answer if I know chord 50? So if you ever have a triangle like this is 20, and this is 25, and I don't know how big that side is, I would be able to use chord 50. I advised you that if you ever see a right triangle, a sneaky thing to do would be to make a copy of it next to itself. And then you can say that 2y is equal to 20 times chord 50, which is 20 times 0.8452. I have my calculator here. 20 times 0.8452. And then I divide that by 2 because that was 2y, and I get about 8.45. So that was how we can use the table of chords to answer questions either about isosceles triangles or about right triangles. But before we can move on from Ptolemy, we have to answer the question, where do these chords come from? How does he get the values on the table of chords? Because right, you printed out the table of chords and it has all these values on it, ranging from 0 up to 2. So chord of 0 was 0, and chord of 180 was 2. But what about all the numbers in between, which is not just 178 more, 179 more numbers, but Ptolemy's table of chords was actually had thousands of entries because he would do like fractions of a degree also. He'd have like chord 0 degrees, chord 0 and 1/60th degrees, chord 2/60ths of a degree, chord 3/60ths of a degree. So he had thousands of entries. And how does he come up with those? Well, we're only going to do about 5 of them. The easiest chord to determine the value of is chord 60. That's chord 60. But what is it? And I want to type into chat. How is it that I know? I don't need to look up chord 60. Chord 60, if I know what chord means, then chord 60 is going to be really, really straightforward. What should the value of chord 60? Yes, Kelsey says 1. And that's right, because this triangle is, if there's a 60-degree angle over here, and it's an isosceles triangle, all the angles are 60 degrees. So chord 60 must equal 1. And if you look at the chord table from last time, you will see that chord 60 does actually equal 1. The next chord that we have the ability to find the value of, like we don't need the chart for it, is chord 90. So you draw this sort of Pac-Man, or this pizza slice, however you want to call it. And I'm going to try to make it a 90-degree angle, which means that the third side of this triangle I'm drawing is chord 90. But without using the chart, everyone think for a minute, how can I calculate that? No chart needed, because this is one of the few that we can just get. How do you figure out that red line segment without looking at the chord chart? Everyone type it in. Well, 45 is something. 45 is the degrees of the other two angles, but 45 isn't the length of that line segment, right? That line segment's not much bigger than 1. And it is close to 1.5, but it's not 1.5. And it is square root of 2. And the reason is Pythagorean theorem is relevant. Pythagorean theorem says that 1 squared plus 1 squared equals, I'm just going to call it x. 2 equals x squared, which is about 1.4. Kind of like the, you remember the 30, 60, 90? The 30, 60, 90 triangle we studied? There's also, some people memorize, and I actually give it to you on the final, the 45, 45, 90 relationships, which are side, side, and the hypotenuse will always be the side times the square root of 2. So some people memorize that when they see 45, 45, 90. I actually give it to you on the final, but you don't actually need it, because if you have a 90-degree angle in a triangle and you know 2 of the sides, you can find the third side with Pythagorean theorem. And if you look at the chord table here, let's look at the chord table from last class period. Here, Ptolemy's table of chords. you can see that when I get down to 90, whoops, it's in the other column. Chord 90, right there, is 1.4. So that's how they would have come up with that. Because the amazing thing about Ptolemy isn't using the table of chords, it's how do you create the table of chords? Because without the table, you can't do any of the trigonometry, you can't solve for any of the missing sides of the triangles. So the achievement is the creation and the determination of these values. And so far, we've seen that chord 60 is 1, and chord 90 is 1.4 approximately. The next chord that we have the ability to calculate is chord 120. In other words, let's say I'm trying to create the chart from scratch. So chord 120 would be saying this. If this angle was 120 degrees and these were both 1, what would the length of this line segment be? Maybe it helps you to draw the triangle kind of like that. And the trick for this one is to split it down the middle. Now, if you split it down the middle, I'll take this red triangle on the left. It would have a 60-degree angle here with a 30-degree angle there. Does anyone remember back in the day what the relationship is between the long side, the short side, and the medium length side of a 30, 60, 90 right triangle? And this will be given to you on the reference sheet. But you might remember we had a day where, why were we? Oh yeah, when we were doing Archimedes, we needed the 30, 60, 90 triangle because it was part of the hexagon. How is the short side related to the hypotenuse? Let's start with that. Yes, the short side is half. How is the long side, sorry, how is the medium side related to the short side? It's bigger. That's right. You multiply the small side times the square root of 3. So that means this piece here is square root of 3 over 2. Whoops. I wrote that backwards. That piece is square root of 3, half of square root of 3. But so is this one. So together, what's this chord? What should chord 120 be? This entire line. Whoops. What should chord 120 be? This entire line segment, which is the combination of this green half that we just figured out and this blue half, which is equivalent. Whoops, that's not blue. So what do those two things together become? Now this I should have more people writing for, because I mean, I'm telling you that one half of that big bottom side is square root of 3, half of square root of 3, and so is the other. So what happens when you add together half of square root of 3 plus another half of a square root of 3?
Wouldn't it be square root of 3 over 2 squared?
That would be if you multiplied it, but we're actually adding the two things together.
Oh.
And Shinyi says square root of 3, which is what I was looking for. Yes, square root of 3. So it was basically I took this half square root of 3 and I doubled it. 2 times 1/2 square root of 3 is just regular square root of 3. And square root of 3, which is about 1.7. If you come over here and look at the chord table, you will see 120 square is 1.73. Now we're not going to do many more. There's really just there's only 2 more that we could actually get. The next one we can get is chord 36. You know what? I'm going to draw my 36-degree angle going this way instead. Okay, does anyone remember? Does this remind us of anything that we have seen in recent times? Have we ever seen a triangle like this before? Oops. Where have we seen a triangle? Where have you seen the number 36 ever? That's right. In the gold, remember the 36, 72, 72 triangle. Now, what we learned was that in a 36, 72, 72 triangle, if the short side was 1, the long sides would be about 1.62. But in this situation, it's the long sides that are 1, so this thing's shorter. Anyone know what this bottom side? What do you think that? How do we calculate that? Well, these 2 triangles are similar triangles. Maybe that will help. Let me put an X here. So we have one triangle that we know all 3 sides of. We have a second triangle that's similar to the first one, but we don't know what the bottom side is. So how would we calculate that out?
Like 162 over 1 equals 1 over x.
That's
Like a
right.
proportion.
That's right. And you would eventually end up with x is 1 divided by 1.62, which is approximately 0.62. And yes, if I go over to my table of chords and you go over to 36, you will see that chord 36 is 0.62 approximately.
Can you go back over that, please? I didn't understand that at all.
So the question is, if I have 2 similar triangles, and I know 2 of the sides of one of them, and only 1 of the sides of the other, what proportion do you set up that lets you find the missing side? So that's the question. So Letitia, how does this work with similar triangles? Like how do you take these 4 things and where do they go in the fraction? In the fractions?
1.62 over 1.
Uh-huh.
1 over X,
Okay, then what do you do
and cross multiply,
to get?
1 over
Uh,
160.
Do the cross multiplying first. What happens? What ends up on the left and right side?
162 over X, so the ones cancel out.
Oh, so cross multiplying, you're not gonna have any fractions. When we say cross multiply, what we mean is take the top left and bottom right and multiply them together. No dividing.
I
And
know,
so what do you get on the left?
1.62 over X.
No, the thing when I say multiply, literally you multiply 1.62 times
I mean,
x.
sorry, X. I meant to say X.
Okay, and on the right-hand side,
At 1.
that's right. Now we're not done yet because we want to get x isolated. So how do we finish it?
You divide by X on both sides.
No, divide by 1.62 on both sides because we want to get the x isolated.
Oh,
So what happens? Divide both sides by 1.62. And what will you be left with? What will the new equation be? Let's say
1
she was,
divided by, yeah,
yeah,
X will be equal to 1 divided by 1.62.
that's right. And then you pop that into the calculator. And that's how you get that answer.
Okay.
So it was similar triangles. Now, this collection we have, so far our collection is sort of small. We have chord 60, chord 90, and chord 36. But there's so many more to get. But fortunately for us, there's only one more that I'm going to show you. And that is chord of 144 degrees, which I picked or which we're able to do because 144 is 180 minus 36, and 36 is one we already know. So if we know some value, there's a way to calculate out 180 minus it. And I'm going to show you how to do that. So the sneaky trick is that chord 36, I'm going to draw a radius horizontally in my circle. And then I'm going to draw a 36-degree angle over here. And I'm going to draw the chord, which we actually know is 0.618. That's just from the chart, 0.618. Now, on the same picture, I'm going to extend that radius, horizontal one, to make a full diameter. Now, what is this angle that I just put a question mark next to? What's the measure of that angle? It is 144 degrees. Which means, and these are also these are all radiuses of 1. So if I join, let's make it purple. If I join this line segment, that big line segment, which is it's pretty, it's a lot bigger than 1, is going to be chord 144. But I don't know what it is. But when I get it, I'll know what chord 144 is. Now, it doesn't look like a lot of information or enough information. But let me separate there's a big triangle here that has 0.618 as one of the sides. The base is this, which is 2, or the big side is 2. Doesn't look like enough information. But there's something about this angle right here that I know for sure. Anyone know what that is? That angle I just highlighted in yellow? It is 90. There's actually 2 reasons why it's 90. One reason is Thales' theorem, which was the very first thing that we studied in geometry, that if you have a diameter, this is always going to be a right angle. But even if you didn't remember Thales' theorem, you could have figured out the other angles, 72, 72. And if this is 144, the other 2 angles of the isosceles triangle would have to be 18 each to add up to 36. Either way, though, this becomes a right angle, which you can now solve. What's x? Go ahead, everyone take a minute. How, now that I've identified, now that I've identified this angle here as a 90-degree angle, you have enough information to calculate out x. How so? Okay, well, Letitia, at this point, though, forgetting how I got from here to here, we're looking at a big right triangle on the bottom. See that big right? See the x2 0.618? So how do you deal with right triangles? How do you figure out the missing side of a right triangle? Let's just get from step, second to last step, and then we'll talk about how did I get from here.
But if that rule, if the right triangle rule was true, wouldn't the big side be double the small side? Oh no.
That's if it was a 30, 60, 90 triangle.
Oh, okay.
How do you find the missing side of a right triangle if 2 sides are known?
I don't know.
Pythagorean theorem. Now, in this case, the a squared, the missing piece is one of the legs. And the hypotenuse is 2. And on my calculator, I do 2 squared minus, I'll just do 0.618 squared. And then I'll take the square root of that and get about 1.9. Let me just make sure that answer's right. Here's the Ptolemy. Chord 144 is 1.9. Now the question is, how did I get from here to here to here? So I'm gonna make a new page because Letitia, you asked about this. I'm gonna draw a circle with radius 1, and I'm gonna stick a 36-degree angle here. And the question I have for you, and Letitia, I'll ask, in this picture, what would this green angle have to be equal to? How big is the green angle?
It's 144.
That's right. Now, if I draw in this third side, if I draw in this blue line and this red line, I get a big triangle. This yellow triangle. Now I'm going to separate that triangle out for a second. Now, still with Letitia, there's only one thing at this moment I actually know about this triangle, right? It's got 3 sides and 3 angles. What's one thing, this yellow triangle here, whoops. What's one thing you could definitely say about this triangle? This is the yellow triangle. I just kind of moved it because there were too many lines. What can you say about that triangle? Any side or angle that you could say for sure?
It's 90 degrees, 190.
Say that again? How about can I go this way? How big is this bottom side?
2.
2. So that's something we have. Now it's also going to be true that this angle is 90 degrees. And that is because the first geometry theorem we ever got was Thales' theorem, which says that if you have a diameter, this angle is definitely going to be a right triangle. Now we don't know this side. But it also seems like we don't know this side. However, from before, we were told that chord 36 is about 0.62. And it's actually on the table also. So we could actually put a 0.62 here. That was the missing thing. And then Pythagorean theorem. In fact, let's go ahead. I have a question for you, which is this one. Wait, is that the one? Hold on. Hold on. In the Desmos. No. I want this question. Let me change this. Okay, here's a Desmos question for you. It says, if for some reason I know that chord 50.
We can't see a screen.
Oh, you don't see a screen?
You're reading this.
You don't see what is chord 130?
Yeah.
Yeah, that's the question. Or I mean, I have it here also. If chord 50, let's just pretend that somehow they figured out what chord 50 was, and we're told, hey, here's chord 50. It equals 0.8452. Somehow someone figured that out. You could actually figure out what chord 130 is. And a way to do that is to draw the 50-degree angle like that and expand this line. And I'm going to draw a couple of more lines in there for you. I'll draw a red line. And I will draw a blue line. Oh, and we'll always make our triangle, our circle have a radius of 1. And I'm going to separate this triangle out because it is a little bit hard to see with all those lines and the circle also. So here's some questions for you. Number 1, what is the length of the red line segment according to this question? I feel like calling on some. Yes?
0.8452.
That's right. Okay, that was given because when they say chord 50 is 0.8452, as long as you understand, oh yeah, that just means in this triangle, The third side is 0.8452. What is it we're trying to find as far as this triangle goes? They're asking for chord 130. My question now is, where is chord 130 in this diagram? And do I have, I'm gonna, Stephen, are you out there? Where's chord 130 in this diagram? Like which keys?
Is it the blue line?
Well, Letitia says blue line, and you're right about that. And that's because this angle here is 130, which makes this chord 130, which puts an X here. Now, there's two more things about this triangle that are going to be very useful. What are the other two things that are going to really help me out in this triangle? Because right now, all I have is a side I know and an unknown side. Stephen, are you out there?
Diameter.
Let me see. Did I lost Stephen? Stephen, put your camera on. Stephen? What's it called? What's it called in Zoom where somebody's like, they're here, but they're not? There must be a name for that. That's what, oh, Stephen, you are there.
I typed in chat, President.
Okay, so Stephen, what other two things do we know about this triangle on the bottom right that are going to enable us to solve for X?
I'm a little confused.
Stephen, in this circle over here, there's a diameter. That diameter is also the bottom side of this triangle. What's the length of the diameter of a circle with radius 1?
2.
And that is going to be the length of the other side of this triangle. Now, this still isn't enough information, but what's the final piece of the puzzle here? Because we can't actually solve for X yet. Because there's one more thing we need to just like say, otherwise we don't have enough information. And this I'll let someone else answer. What can you say about this angle over here, which is also the angle over here? It is a right angle. And when you have a right angle, you can do the Pythagorean theorem. X squared plus 0.8452 squared is equal to 2 squared. X squared is equal to 2 squared minus 0.8452 squared. X is the square root of that. With the scientific calculator, you could just sort of type that all in one shot. My calculator had to run out of batteries. Oh well. Okay. Square root of 4 minus 0.8452 squared. And we get the answer, which is about 1.81. And if you go over to the table of chords, you will see that chord 150, chord 130, I mean, is 1.81. Now, you don't need this is how you should do it, like on the final and all that, and on the homework. But if you like, for studying purposes, I don't believe I don't actually give you this formula on the final.
Can you put back what the answer was, please?
Yeah, 1.81. That's
So you have an assignment for us still?
yeah.
And then when do you want that?
So that assignment's due on Wednesday. So because the final's on Thursday, that homework's due on Wednesday, and I'm actually not going to give you a homework assignment tomorrow. So this is the last of the homework assignments.
Okay.
Now, if you want, I could actually turn this into a formula. It would look like this. This is chord alpha.
I
This
didn't
is-
get that answer, so I'm confused.
so did you do x squared plus 0.8452 squared equals 2 squared? Or did you,
Yes, I did that.
and did you first do the 0.8452 squared?
Yeah,
Okay, let's see what that equals. That's 0.7144, like that. Are you at this? Did you get to this stop? This part?
yeah.
And then did you subtract 0.7144 from both sides?
No, I didn't do it that way.
Oh, okay. So what did you do at this point?
I moved 0.8452 square over to the other side.
Oh, so you didn't turn it into 0.7144.
No,
Okay, that's fine. You can move the 0.8452 the square to both sides. So you have this. Is that what you're looking at?
yeah,
Okay, and then what'd you do?
I squared both of them,
So you get
which
4
is 4
minus
minus
point seven. What was it? 0.7.
0.714362.
Okay. And then what'd you do next?
I subtracted that number from 4.
To get
3.2856.
and then how do you finish?
You square that number.
Square. So you got 9. Did you have that square root? Because it's x, it has to be less than 3.2. So I think we found the problem. You should instead take the square root, not the square.
I square rooted it.
Oh, okay. Oh, you did square root it.
Yeah,
So what'd you get?
1.8126224.
That's the answer. That's the answer. That's over here. So you did get it. Now, if you're somebody who likes formulas, which I personally am not like a big formula lover, but I will tell you that we could go like this: chord 180 minus theta squared is equal to 2 squared plus chord. I'm sorry, I'm getting myself the hypotenuse. Yeah, wait, something's wrong here. Hold on. No, the hypotenuse is the 2. So chord 180 minus theta squared plus chord alpha whatever squared equals 2 squared. I don't like formulas that much. Some people do though.
On the final, so we're just gonna get a question and have to draw the picture ourselves. Like, I'm concerned that I'm not gonna be able to set this.
Mm-hmm. That's right. The
Circle
question
up.
it's always the same picture, But yes, the question will be, I'll tell you a chord, chord, like I did here, chord 50 equals this. What's chord 130? So at that point, I mean, it always is going to turn into this thing that I have on the bottom. You're always going to end up doing 4 minus the square of the known thing and then taking the square root of it. We've had this sort of like question about like, how much do I need to memorize and how much do I need to like understand the concept. So on the bottom here, if you feel like you're having trouble understanding the concept, this formula would get you the answer.
Yeah, but
However,
the formula is not going to be on the formula sheet.
no, that won't be on the formula sheet. So what I would encourage you to do is make a flashcard, that kind of has this on one side, 50, chord 50. And then on the back of the flashcard, I'd have that. See, so that would remind me, oh yeah, I can get like 180 minus by kind of putting both isosceles triangles, together like a jigsaw puzzle. Anyway, you practice it for homework. So here's the chord 50 picture, triangle. And here's the chord 130 picture. And they see how they kind of fit together. They actually fit together to make a nice right triangle. Ooh, so I am going to move on though, only because I have more to do. I don't want to run out of time. Now, between the year 100 and the next 700 years, math, after Greece got like conquered, they stopped doing math. And what happened is math moved over back to the Arabic countries. Remember, we started with Babylonians. So between the year 100 and for the next 1,000 years, most of the math was being done in the Arabic countries and also in India. And our next mathematician is from the year 800. And it's somebody named Al-Khawrizmi, was like his last name, Al-Khawrizmi. And the word Al-Khawrizmi got turned into, eventually, the word algorithm was named after Al-Khawrizmi because it, kind of sounds like algorithm if you sort of turn it into English or whatever, Latin or whatever language. Al-Khawrizmi is we still say the word algorithm every day. Oh yeah, it's the algorithm. Google algorithm. Did you know that algorithm was named after a person, Al-Khawrizmi? Al-Khawrizmi wrote a book about how to solve equations. And if you ever had an equation like this, where you had to add to both sides, they called that process al-jabr, which means to restore. That's where you add to both sides of an equation. They had a different name for when you subtract, a different expression from when you subtract. I forget what that one was called. But the one where you subtract, when you add to both sides, was called in Arabic al-jabr, which eventually turns into the word algebra. So Al-Khawrizmi is responsible for 2 words that we still, every single day you hear people say, oh, we got to learn algebra. We got to, 8th grade, more students need to do algebra. We learn algebra every day practically if you're in education. And then you hear the word algorithm. Those are both traced back to this Arabic mathematician back in the year 800. the thing that he's really famous for is a method of solving quadratic equations. And I'm going to teach you the method right now. Now, we studied this, we actually learned how the Babylonians answered this question, and it was a whole annoying process. Al-Khwarizmi's method is a lot prettier. And it is geometrical, so it's going to have like a picture with squares and rectangles. And it's called, actually, I'm not going to tell you what it's called yet. So on your notes, draw a square that's going to represent x squared. And then on top of this square, draw a rectangle. And whatever number is right here, put that number over here also. So that rectangle's area is 10 times, x is the base of the of that rectangle. So this picture represents x squared is the area of the square, and 10x. Do you see how the 10x, because the base is x, it shares the base with the square. Now this combination of figures, according to the question, what is the area of this entire yellow thing? You can type it into the chat. But what numerically, like what's the actual, but you're right, 10x plus x squared is the combined area, but according to the question, what number, like what's the actual numerical value? And it is 39, because that's given. It says we want the area to be 39. And now comes the sneaky trick. We're going to take the square and just copy it. But we're going to take this rectangle and we're going to cut it down the middle into two pieces. And we're going to leave the bottom piece where it is. And we're going to take the top piece, and we're going to move it over here. So we get the L-shaped thing. And my question for you is, as a number, what is the area of the L-shaped thing? Everyone think about that for a moment. What's the area of this, according to the question, the given information in the question, what should the area of this L-shaped thing be? And yes, Letitia, Shinyoung, Kelsey, I'll say 39. And that's right, because we didn't lose any area when we turned the big skinny rectangle into the L-shaped thing. And now comes the awesome idea, which is, what if I fill in the missing corner of the L-shaped thing? What is the area of this green thing? Type in, what do you think the area of that green thing is? Well, the green thing, Letitia, won't have X's in it because it's just, we actually know it's a square. And we know that 5x, Letitia, is the area of the green of these pieces here. It's not the side length. The side length is just 5. See this 5 here? That makes this 5. And this 5 here makes that 5. So this green square, surprisingly, it's not having an X in it. It's literally just an area of 25. I could see expecting that green thing to have an X in it because there's so many X's in this. There's so many X's in this picture, but this is actually the one thing that I don't have to put with an X in it. Now my question is this: what is the area of this entire? I'm outlining it in purple. What's the area of this big new square that didn't exist before? Janet says 64. Yes. Why 64, Janet?
It's the sum of all the areas, with the 39 plus the green area, rectangle or square rather.
That's right. Now, if I have a big square, I'm going to make this purple square. I'm going to take away all the other lines for a minute just to kind of, now that we have that the new square has an area of 64, what's the side length of that new large square then? And that is just 8 because the square root of 64 is 8. This means that this entire side length is 8. We are finally in a position to get X. If the entire side length of the large square is 8, what's the missing piece? What's the X at this point? And yes, it is 3 because we had 5 already. Now, good news for you. I'm going to show you how to do this without drawing the picture. But I think I want to put you in groups for a few minutes to try to first do it with the picture. If you go over to the Desmos, go over to question 2. I am going to turn this into like more of a formula that doesn't, you don't need to draw all these squares and stuff. But I want you to talk with your group members. Can you, if I give you like let's say 7 minutes, can you try to answer this question with the drawings? Oh, the Desmos? The Desmos link is over here. Now, I promise I will give you sort of a method that does not need all these squares and rectangles, but I'd like you to try to do it with the squares and rectangles. If you get really confused, I am going to turn this into more of a formula after I bring you back. So I'm going to put you into groups for about 7 minutes starting now.
Can you just show me the slide before this for 1 second?
Yes, I'll leave this up.
Thanks.
Once I put you into the groups, that slide's going to disappear though. So do you
I got it.
Okay, so let me put you in for 7 minutes. Again, this is going to turn into more of a formula or there's a way that doesn't involve drawing stuff. That's what I'm telling you. But see what you can do now that I've shown you about the basically converting this skinny rectangle into an L, and the L picks up a square on the corner, and that somehow helps you answer the question. So go into groups now, see if you can answer question 2 on the Desmos. Okay, everybody. So with the geometrical process, it would look like this. By the way, this rectangle you draw on top, it doesn't have to be like a tall, skinny rectangle. You could just make it. It's probably easiest. This is not like drawn to scale necessarily because we don't know how big x is. Like, is x bigger than 12? Is x less than 12? We don't really know. So you could just draw like this. Step 1. Step 2. X6, X6. Step 3, very critical step. What's the area of that little? That it may not be little, maybe big, depending on how you drew it. But what's the area of the
36.
new? What's that?
36.
36. So then the area of the entire thing is going to be 85 plus 36, which is 121. So basically, you end up adding this number, 85, plus half of the 12 squared. That's what ends up happening eventually. Then you take the square root of 121, which is 11. 11 is now the length of the entire side of the square. You finish out by subtracting 6 from 11 because 11 is this entire thing. And you get 5 as the answer. Now you might say, I don't like this. I don't want to draw squares and rectangles. I don't know how tall to make this rectangle. So maybe you will like this if I tell you that I will permit you on the homework and on the final to go like this instead.
Sorry, can you just go back for a second and
Yeah.
show how you got 5? Like
The 5, yes, because once I took the square root of 121, 121 was the area of 121 was the area of this entire square, including the the little square that I put in.
Mhm.
So what's the side length of a square that has area 121?
11.
So that 11 represents the side of this square. 11.
But
But
isn't the
see-
side length x, is the
X-
side length x plus 6?
Yeah, the side length is x plus 6, right? Because x was from here to here, and 6 was from
Got
here.
it. Okay.
Now,
yeah,
I
I
rem-
multiplied by accident.
now you might like drawing this stuff in because of the logic of it, but I will tell you that a thing when we teach this, like in modern days, they make it look like this. You may like this, you may not, but I'm just going to tell you that if you take half of 12 and you square it, you get 36. 36 is the area of that little square. And if you add that 36 to both sides, I'm going to write this as you add that 36 to both sides. The right side becomes 121. The left side turns into x plus 6 squared. And you might say, wait, how do you do that? Basically, you are permitted to change this into x plus 6 squared. That's what it would equal if you do x plus 6 squared. Again, you may not like this method. You might prefer the drawing the square method. If you don't like either of the methods, well, you better pick the one that you dislike the least. But some people like to, those are like nowadays, they actually teach this. Oh, and what do they call this? Those people who are algebra teachers, what do they call this process I just wrote up on the board, on the screen? Hold on, where's my chat? Where's my chat? Where is my chat? It like disappears from my screen. I see someone type something. 2 people. I just see a number 2, but I don't get to see the chat. Hold on, I'm gonna keep looking for it.
It's a
There it
factorial.
is. Oh, so factoring, well, this step from here to here is factoring, but this entire process of solving this quadratic equation this way has its own fancy name.
Completing the square.
Yes, we call this process completing the square. And we call it that. Nowadays, we say, oh, by putting a 36 here, we turn it into perfect square. But this process is really more naturally, here I really completed the square. Literally, I took that missing piece and added it in. Oh, I see some people on the chat. So Shenyang is shocked because have you taught algebra before and used the completing the square expression without knowing that it had the geometrical interpretation? Is that why?
Yeah, I didn't know anything about the geometry interpretation.
Yes. So it's very famous and it's very cool. So Al-Khwarizmi did it this way, but nowadays people do it this way. They don't draw the stuff in. And I will permit you to do it either way. If you're wondering though, like this step here, it's always going to be x plus. This thing here is always going to be x plus, and this will always just be half of the 12. So even if you're not like fully understanding where it all comes from, you can still do this method. So this is very famous, completing the square. This is pretty much a guaranteed final exam question because it's such a famous thing. The question's always the same. It's just what number goes here and what number goes here. It's always going to be x squared plus something x equals something. You'll end up eventually dividing the 12 by 2, squaring it, and adding it to the 85. And you'll see for homework, let's take a look at what the homework looks like. Homework, assignment 13. Homework 13. So homework 13, question 1 is the chord. Given a chord, find the chord of the supplementary angle. And question 2 is completing the square process.
So on the homework, we have to draw it, right?
What's that?
On the homework, we have to draw the squares, right?
You have to do completing the square method. You can't, you have to either do it the way you see on the screen right now, or you have to do it this way. I'll permit you to do it with the drawing the squares or this way, but no other way. These are the only 2 ways that if it says completing the square, it must either be this or this. So no factoring, no quadratic formula. How are we doing time-wise? Okay. So we have 2 more things to do today. I feel like I want to change the order. So I'm going to skip ahead. I'm going to do the thing in the 1600s before because it's easier than the 1500s. So skip the 15. Oh. So math came back to Europe in a very specific year, the year 1202. So math left Europe from 100 AD. For over 1,000 years, math was being done elsewhere. Until Fibonacci, who was Italian, went to the Arabic countries and learned their math. And he also learned their numerals. Which are now called the Hindu, Arabic numerals. And, base 10. So they developed our commonly used 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know what they were doing in 1202 in Europe before the Hindu Arabic numerals. They had Roman numerals and stuff like that. That were just terrible. But Fibonacci went and learned about these 0, 1 through 9, 0 through 9 numerals and the base 10 system and the algorithms for multiplying, dividing that they developed nicely in the Arabic and in India. And he brought him back and he wrote a book that's famous that's called the Liber Abaci, which means the book of calculation. You see, Abaci is a little like the word abacus that in China they used to do their calculations. This book had all kinds of methods of multiplying, dividing, fractions, square roots. But Fibonacci is mostly remembered for, if you go to slide, skip 3, 4, 5, 6, skip 3, 4, 5, and 6. I think I have to do those tomorrow. Slide 7, though. So Fibonacci had this famous riddle. A newly born pair of rabbits becomes capable of reproduction at age 1 month. After a gestation period of an additional month, their first offspring are born. The additional pair reproduces in the same fashion as the first pair. How many rabbits will there be in the nth month? So this was the riddle. So it's a little bit confusing. The idea is I have 2 rabbits. Here's my rabbits, which is 1 pair of rabbits. But after 1 month, 1 pair of baby rabbits. And after a month, I still have 1 pair, but I have 1 pair of adult rabbits. But in the next month, I should give them a color. But the next month, my adult rabbits are still alive, but now they have a pair of baby rabbits. So now I have 2 pairs of rabbits. The next month, my red rabbits are still alive. My red rabbits had a new pair of babies. Actually, I should make the babies smaller. Okay, why don't I do this? I'll make baby rabbits small and red rabbits bigger. So originally, they were small red rabbits. And originally, I had small green rabbits. Now the small green rabbits have grown up to be adult rabbits. So I have 3 pairs. But it gets interesting the next time, because now I have the red rabbits are still alive. The red rabbits have a new pair of baby rabbits that are purple. the blue rabbits grow up to be adult blue rabbits. The green rabbits are still alive. But the green rabbits have now, they were old enough to have their own baby rabbits. And now there's 5 pairs. And when I write these numbers, I have 1 pair originally, 1 pair after 1 month. I'm not distinguishing whether they're adults. 2 pairs, 3 pairs, 5 pairs. 1, 1, 2, 3, 5. Anyone want to say what the next 2 numbers are? You could type it into the chat. Actually, why don't you just do the next one by thinking how many pairs there's going to be. The old rabbits are still there. They're each going to have a pair of baby rabbits, and the baby rabbit's going to grow up. So how many rabbits are there pairs the next month? We currently have 3 adult pairs and 2 baby pairs. So how many rabbits are there going to be in the next month? Someone want to type it in? Those adult rabbits don't die, so there's at least 3 pairs. Yes? It's not 7 though, but it is 8. Why 8? You have the 3 adult rabbits, pairs, that are still there. They each have a pair of baby rabbits, so that's 6. These 2 baby rabbits are still alive, so that's 8. But now you might know, and this is a famous thing, the number pattern. 1, 1, 2, 3, 5, 8. What's the shortcut for getting the next number that only takes 1 second to do without even thinking about rabbits and who are babies and what rabbits are still alive? What's the next number in the sequence? Or what's the pattern that lets you get it without worrying about rabbits? Okay, that's all right. I will tell you. The general rule is add together the 2 most recent numbers, and out comes the next number. If you don't believe it, watch this. 1, 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 5 plus 8 is 13. 13 plus 8 is 21. 13 plus 21 is 34. This sequence of numbers is called, nowadays, the Fibonacci sequence. So as a challenge, what's the next 2 numbers? Everyone take a moment. After 34, write down what the next number of pairs of rabbits are. Okay, good. Yes, 34 plus 21 is 55. And then let's go one more term. And then 89. So what's funny about Fibonacci is that he wrote this massive book that brought math back to Europe after 1,000 years of Europe doing nothing in math. And so he's very influential. He taught Europe base 10. But the one thing that he's remembered for, is what's called the Fibonacci sequence, the pattern of numbers that teachers like to ask their students, find the next 3 numbers of this sequence. It's probably it's one of the least important things in the Fibonacci book. It's just like a riddle that doesn't have like any massive importance, except it's kind of fun to try to figure out what the shortcut is. But if you ask any high school math teacher, what's the Fibonacci sequence? They'll say 1, 1, 2, 3, 5, 8, and every number you get by adding the previous two. They probably don't know that this started off with a question about rabbits that, well, where the brothers and sisters have babies with each other. Most people don't know that's where the Fibonacci sequence came from. So on the final, maybe I say if 34, this is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. If 34 and 55 are the 9th and the 10th Fibonacci numbers, what's the 11th Fibonacci number? Okay, this is let's do a 5-minute break, because the thing we have to do after the break, I have to decide. We have something that's pretty easy and something that's pretty hard. And then what we do on tomorrow is pretty easy. So there's only one more really hard thing left. I just want to decide, do I do the hard thing today, get it over with, and do 2 easy things tomorrow, or do one of the easy things today, and do a hard and an easy tomorrow? I'll decide during the break. Okay, everybody. Or maybe I'll do a vote. I want to do the easy thing today, but then tomorrow you're going to be regretting it, maybe. Maybe we'll do a vote on it. So here, I'm going to do a break now, 5 minutes. You guys, I'll be here during the break. So if you have questions for me, I'm right here.
Professor,
Yes.
I won't be here tomorrow.
Oh, okay. So I think you're going to want the hard thing now, because you're going to you might have trouble learning the hard thing from a video. The easy thing you'll be able to learn from the video that when you're out tomorrow. Wait, tomorrow you're out? I thought you were out Wednesday and Thursday.
No, I'm here Wednesday online.
Oh, I see. You're
Yeah.
traveling tomorrow. I'm going to do the hard thing, only because the easy thing you could probably learn from the video and the notes, but the hard thing, you're not going to be able to. The final is in person on Thursday. And Wednesday's in person, but optionally. Like if you want to come to study for the final, I'll be there on Wednesday. And I'm going to try to set up a Zoom, but I can't promise that the Zoom works on Wednesday, because I'd be doing it from the school.
On last night's homework, number 7,
Yes, let me take a look at that.
or Thursdays.
It's this, right? Homework 12?
I think so.
Okay, let's take a look at that. Oh, is this the one that I forgot to did that? Oh, no, number 6 says skip this one. 7. Yeah, it's 14 over pi. Sorry. Yeah, it's always double the rate, double the side length, and divide by pi.
Okay, what did we go over that in class?
Yeah. I had said that it was about I said it was about 2/3 of the length of the 2/3 of the length of
Yeah,
the
that's what I said. I did 2/3 of 7.
yeah, but it's not 2/3, it's 2 over pi times 7,
Okay.
which is close to 2/3. I didn't draw this picture very accurately because it looks like it's about half.
Okay. I just don't remember us talking about pi, but maybe I just missed it.
So this figure, this quadratrix, its main purpose is not for trisecting angles, but it's for squaring the circle. So that length on the bottom having pi on it was important for that. I didn't say a lot about it. I just said that bottom piece has pi in it, which makes it useful for squaring the circle. So the rule is double it and divide by pi. Double the side and divide by pi.
Okay.
That was one I didn't even give any like justification
Explanation for her.
Right. I just said, here is just a fact for you.
Okay.
Oh, hold on a second. Professor, you had put a comment on one of my homeworks that it was 2 different homeworks. It was both problem 7s, and I would like to speak to you about them.
Yeah, yeah. What was the story with that? What did I write so I can remember?
1, I didn't do 7. I think I didn't understand it. That's why I didn't do it.
Okay.
And then 2, I think I figured out the wrong calculation, and it was another question that you asked me that I would like to go to that work and see.
Yeah, which one? What homework number and what question number? I know it's question 7, but what and Shinyang, yes, 2 AB over pi. Listen,
Homework,
maybe why don't we talk when the class ends, because I want to bring everyone back.
okay.
When I write a comment on a homework, it's not like that you lost points for it necessarily. It's more just to let you know so that you can know that it's right for the final. If you get most of the questions right on the homework, usually, did you get 100 on the homework?
I did, but I still
Okay.
would like to know.
What it was that you got wrong. Yes. Okay, everybody, welcome back. This thing that I've been playing up as the hard thing, it's not going to be so bad because there's going to be a formula, and that formula is actually going to be given to you on the reference sheet. You could look, here's the reference sheet. I actually have to update this reference sheet because there's 2 things on this reference sheet that we don't need. But table of chords, this thing we learn, we haven't learned this yet. Log table, 2 over n table, useful formulas. Here's some geometry. I'm cutting this. This isn't needed. and I'm cutting this. I'm putting instead other things that are useful. But here on the reference sheet, there is a very scary looking formula right here. So it's a good thing I'm giving it to you. We fast forward now. So after math comes back to Europe in 1202, they sort of start advancing math pretty rapidly. And a question, we mentioned that the Babylonians knew how to solve quadratic equations. You know, Babylonians knew how to do questions like ax squared plus bx plus c equals 0, even back in 1600 BC. They knew how to do that question. But they wanted to know, is there a way to solve what's called a cubic equation? This is quadratic. A cubic equation is like, hold on, let me find my notes on this. A cubic equation is like x cubed plus 15x squared plus 36x minus 450 equals 0. That's called a cubic equation. And for 3,000 years, from the time they figured out how to do quadratic equations until the 1500s, it was believed that this wasn't really possible, that there was no way to solve cubic equations. Until the year 1545. In Italy, there was an interesting character whose name is Cardano. And Cardano was an interesting character because he was a physician and he was like a well-respected physician who even was like, I think he was the Pope's physician. So that makes you have to be pretty good. And he was like he was a gambler. And he was just he was like one of the most famous people in Europe. And he was a mathematician. Well, this is kind of a funny story, a bit. In the year 1515, somebody named Del Ferro figured out how to solve certain cubic equations. Specifically, cubic equations that look like this. Has no x squared in it. These type of cubic equations that have an x cubed and an x, but no x squared, today are called depressed cubics. And Del Ferro figured out how to solve this type. But unlike today, where he would publish it in a journal and get credit for it, back in those days, if you published it somewhere, if you wrote it down, someone else would probably steal it and go to another country and say they invented it. So back in those days, they would keep their math sometimes secret. So what good was it? Well, back in those days, they would have contests where mathematicians would face off against each other, and each one would try to solve the other person's questions. Like I give you 10 questions and you give me 10 questions, and then we come back a week later and see who answered more people, who could answer more of the other person's questions. And whoever would win the contest would be celebrated and maybe get a job as a professor, or some rich person would just give them money. So Del Ferro kept his formula a secret. Now, Del Ferro, he died. And he told his student, so in 1526, Del Ferro died. Of course, these numbers aren't, this story is not important for the final, but I hope you find it interesting. Del Ferro dies, and he tells the formula to his student, whose name was Flor. So now Flor has the secret formula, and he wins a lot of contests with the formula. But I think in somewhere around 1540, Flor has a competition with someone named Tartaglia. And in this competition, Tartaglia has to try to answer questions of this nature, x cubed equals 9x plus 28. And he actually figures out the formula himself. So now both Flor and Tartaglia know how to do this question. And here's where Cardano comes in. Cardano wants to know how to do these questions. And Cardano goes to Tartaglia and says, please tell me how to do these questions. And Tartaglia says, well, he says no at first, but Cardano is really famous, so Tartaglia eventually tells him, but makes him sign an oath of secrecy that he'll never tell anyone how to do it. Now, the holy grail of math at this time is to figure out how to do cubic equations that have an x squared term in them. And Cardano, with one of his students, figures out that if you use this formula, the formula for doing these questions, there's a way to like convert a question like this into another question that's like y cubed equals py plus q. And when you figure out what y is, you could then use it to figure out what x is. But the process, so Cardano, though, isn't allowed to publish his new method for cubics because it involves the depressed cubic that he swore not to tell anyone. But then Cardano had an idea. He said, well, Flor knows the formula. He'll never tell me because his master, Del Ferro, told him not to tell anyone. Del Ferro's dead. But Cardano goes to Del Ferro's wife, his widow, and says, can I look at his old notes? And finds the formula there. And then Cardano publishes one of the most famous math books ever written in the year 1545, called Ars Magna, which means the great art. And in it, he publishes the formulas for all the cubic equations. Well, Tartaglia gets really mad because it involves his formula, or he figured out the formula also, and Cardano swore to secrecy. But it was already published. Can't put the toothpaste back in the bottle. So we still call this formula, this one, for this thing that Del Ferro invented, that Tartaglia reinvented, that Cardano promised not to tell anyone. We still call it the Cardano formula. And I'm going to teach you what it is. So here's the way it works. Here's how to solve an equation like this. Now it becomes a pretty ugly formula. Like when you look at the reference sheet, you say, no, I don't want to, where is it? On the reference sheet, it looks like really intimidating. But let me show you the general idea that once you understand, the formula is going to seem pretty easy. Step one. Take the 28 and divide it by 2. Step two, always divided by 2. Whoops. Step two, take the 9 and divide that one by 3. Step 3 is to take the 14 and square it and subtract the 3 with the cubes. So this 14 came from here. Those 14 and 3 end up here and here. So you use a calculator for that. You get 14 times 14 is 189. No, it's not. Yeah, 189.
You got the 3 from the cube?
9 when I divided the 9 by 3.
Yeah, but why are you dividing by 3?
Oh, so you don't want to know.
Oh, okay.
14 times 14 is 196.
196, sorry. 196 minus 27 is 169. And now we are prepared to assemble the answer. Now the answer looks really ugly. It always looks like this. Cube root of something plus the square root of something plus cube root of something minus the square root of something. And what goes in these places? The 14 goes here and here. That's the 14 from up here. And the 169 goes in those 2 places. And it's finished. Well, we could go further sometimes, but let's just say this is the main thing. So I'm going to have you try to do this with a different question. Will you please do it with this one? X cubed equals 6x plus 40. You will get an expression that looks like this. And you're going to fill in. There's going to be a number here and here. It's going to be the same number. At least, this and this will be some number. And this will be some number. So everyone, try to follow the process and fill in what's the blue and what's the green. Hold on, let me just 1 sec. I'll be back. Let me just make sure what's here. No. Oh, there's no Cardano questions in here. Wait. Hold on. No. Okay. So you don't type it in yet, but what goes in the blue spot? And the blue spot's actually really easy. And then the green spot's harder. So everyone take a minute to ponder those 2 numbers. Someone type in the blue, because the blue is really, really a fast one. What you go in the blue spot? It is 20. Half of the 40. Now the green's a little bit annoying. Someone want to, you can unmute. What do I type into a calculator to get the green thing?
$400 minus 8.
That's right. Steven, are you there? Steven?
Yes.
Why 400 minus 8? Where did 400 minus 8 come from? How did Letitia, why'd she do 400 minus 8? Where the 400 and the 8 come from, you think?
I'm still trying to work it out myself.
Okay. Is Mariella, you there?
I'm here.
Where does the 400 minus 8 come from?
20 square minus 2 cube.
That's right. And this is the answer. Now, when you turn this into a formula, I'm going to show you now the reference sheet. That formula makes it look a lot harder than it is. See that with the formula? So this formula here makes it look scary. But yes, that formula will work, and I'm going to give you that formula on the sheet. Oh, Stephanie, what do you mean by the last step? Do you mean where did the 392?
No, I did minus 2 squared by accident. So then
Okay.
I'm changing it in my notes to 8. So then it's 392.
That's right.
Okay.
Now you see on the screen the formula. This formula says Q over 2, that was the 20. And then inside the square root, Q over 2 squared minus P over 3 cubed, Q over 2 squared minus P over 3 cubed. So this will refresh your memory about the process. And I'm not going to derive that formula. I'm just telling you that this formula is the magic formula. Now, sometimes you can go further with it. Like, let me just erase this down here for a second. Like it turns out that 169, if you ever notice that this thing happens to be a perfect square, you can keep going maybe. And if you get lucky, 14 plus 13 is 27, which is a perfect cube. And 14 minus 13 is 1, which is also a perfect cube. Cube root of 27 is 3. Cube root of 1 is 1. And you can go further. But usually you can't. Usually you have to leave the answer in ugly form. Because usually it's an irrational number.
Can you just explain again, like how we use that formula to remind us of the steps right here?
Yes. 9x plus 28. So that formula written down says Q over 2 plus square root of Q over 2 squared minus P over 3 cubed plus cube root of Q over 2 minus square root of Q over 2 squared minus P over 3 cubed. So this number here is the P, and this number is the Q. So you could just literally go like this and say, okay, what goes here and here? Well, according to the formula, is Q over 2, which is 28 over 2. And what goes here and here? I look at this thing, and it says Q over 2 minus P over 3 cubed. In other words, 14 squared minus 3 to the third. So that's how the formula can refresh your memory about what goes where. Now, the formula doesn't tell you what's P and what's Q. It just says this. But there's only two numbers, right? X squared equals 9x plus 28. P is the first one, Q is the second one. And usually I make this number even so that I don't have to deal with decimals. And usually I make this number a multiple of 3 so I don't have to deal with decimals. How are we doing? Okay, hold on. Now, since there's not a lot of time, well, yeah, why doesn't everyone do question 3, which is another one of these? X cubed equals 39x plus 380. Now, if you have a calculator, I'd be interested in decimals. Like after you get this big ugly answer, could you type it in? Sometimes it's ugly. Oh, I lost my other answer. Hold on. Remember this one? X cubed equals 6x plus 40. And it became cube root of 20 plus root 392 minus cube root of 20 minus root 392. You could actually type that into a calculator, but it's actually pretty hard. On the final, I don't make you do it. I'm just curious for us right now. Why doesn't everyone work on? Oh, I'm saying stuff, but I wasn't writing it. I said this. You could type this into a calculator, and out comes some number, decimal. Do that for this one though. So everyone work on this question. It's on the Delta Math. It's on the Desmos. It's question 3. Oh, try to type into the calculator at the end.
Professor, can you leave the last slide up?
Do you mean this one?
Yeah, thank you.
I'm sorry, what do you want us to type into the calculator?
Say that again.
What do you want us to type into the calculator?
After you get the answer, the big ugly thing, that equals some number. So what is it?
I don't have a calculator where I can do the cube.
Okay, do you? Oh, it doesn't have.
I can do square roots, but I can't do cubes.
Okay, so You could also, on your computer, type in Desmos, desmos.com / maybe scientific. Let me see. Now, if I want to take cube root, I think I have to type 3 and then this button. No. Oh, I see. Huh. You type this and then you type 3 for cube root and then the number. So you can do it on Desmos with this button right here. Uh-oh. Did I make a mistake there? Oh, 190. Yes. So Letitia, were you able to access Desmos.com?
I'm on the Desmo.
Here, I'm gonna put a link. Desmos.com / scientific. Here, I'll put a link to that. I should have thought of that before. Let me check out the
It's not
Desmos.
giving me an answer. I don't know how to. Oh, okay,
How to type it in to Desmos?
I got it.
I have Desmos open in 2 places apparently, so it won't, I can't find the other one.
Okay. Oh,
I'm
so
pretty sure I don't, but it was telling me that I do, so I had to like exit out, so I have to go back in.
let me look at the dashboard and see. Anyone? Okay. So we're on question number 3. Is that right? Or question? No, question 3. There. Okay, let's see if people have responses.
I'm still working.
Uh-huh.
Me too.
Are we rounding this to any value?
Three decimal places.
I just submitted my answer.
Let's see.
Did we do number 2?
Did we do number 2? No.
Okay.
We did a we didn't do number 2. We did a different question. Wait, no, we did number 2. That was the one with the 181, remember? Sorry, the 121. Oh, no. It's not 120. Wait, is it 85 plus 36?
X was equal to 5.
Right. It was 5 because it was 11 minus 6. Right. Yeah, we did do number 2.
Was
Okay,
my work
everyone.
right in number 3?
Yeah, so for number 3, the answer, and it's better. So Letitia, I saw your answer was off by a bit, but you probably by doing, you didn't need to do the actual square root of 33903. You could have just typed it all in just like this. That way if you made a mistake in the square root, see, I don't even know what the square root of 33903 is because I typed this all in one shot. So I got
Where
3
did you
points.
get 33903 from? I'm confused about that.
The 33903. The 33903 was 380 over 2 squared minus 39 over 3 cubed. That's what ends up inside. So you take half the 380. Let me go back to,
So it's 36,100
well, let's
minus
see.
27.
380 over 2 squared, 36,100 minus
Yes.
39 over 3 cubed. So 33903. You know what you might have done? Did you do parentheses 39 over 3 cubed? Or did you do 39 over 3 and then cube it? Did you get 2197?
What happened? I'm not even setting up I don't even understand what you're doing right there because that's not how I did my math. I did the math how you showed us.
So you did 380
Is
over 2
9.
squared. What's 380? What's 380 over 2 squared?
Yes.
And then did you do 39 over 3?
39 over 3 cubed
Yes.
is 27.
39 over 3 cubes is not 27. It's 2,197.
Oh, I made a mistake and put 9. I
Okay.
forgot the 3.
Okay. So that is where that's where the error was. 33903. And when you type it into the calculator, you get 9.00. You get 9.00979. Which is approximately 9.01. The answer is irrational. So now we're up to the last thing
I
for
need to
today.
still work this out.
Well, you know, on the final, you leave the question answer just like this. So yes, you do want to get the 33903 because that's part of the answer. That came. You know, 190 squared minus 13 cubed. Now, the last thing, so this part wasn't too bad because I'm giving you the formula. So you might wonder, well, what is it that I've been so like saying, oh, we got to be careful, there's something really hard coming. I mean, this is annoying, but since you don't have to understand why this formula works, it's not so bad. But Cardano's big thing was not publishing this formula that someone else made up. Cardano's big thing was showing how to solve any cubic equation, including a cubic equation that had x squared in it. So this equation, which I wrote down here, x cubed plus 15x squared plus 36x minus 450 equals 0. So this looks really hard. And we can't use that formula because that formula doesn't work if there's this x squared term. We have to do something about that. And here's what you do. Take this number, the 15, and divide it by 3. I'm going to say positive 15 is equal to 5. And then replace x with y. I'm going to say this with y minus b over 3a, which in this case is y minus 15 over 3 times 1.
What?
Yeah, do you get this?
I'm really confused. Where you get 15 and 3 times
Well,
1? I'm
well,
confused.
You're going to take whatever number's here, and you're going to divide it by 3. I wrote it out as a formula here, but because there's technically a 1 there, but there's always going to be a 1 there, so we don't really need to worry about it. But whatever number's there, divide it by 3. I'm not telling you why we're doing that. I'm just telling you this is what we do. And then we're going to replace every x in this question. Every x in this question is going to get changed into this. There's 3 different x's. Is going to get changed into a new thing, which is y minus whatever 15 here. So change x gets changed into y minus 15 over 3, which is y minus 5. If this was an 18 here, we'd replace the x with y minus 6. So let me just make a note here. What if the question was x cubed plus 21x squared minus 7x plus 3? Letitia, what would I replace the x with in this situation?
7. Y, sorry,
Not the
y
number
minus 7.
Just say it again.
Y minus 7.
That's right. And just to make sure, because there's one more thing that can happen, what do you think would happen if there was a minus here?
Confused by that.
It becomes a positive.
That's right. So let's say 15x minus 19. What do you think I would
Y
replace?
plus 10.
That's right. So this is kind of a weird thing, but in general, we replace x with y minus b over 3a, where in this case b is negative 30 and a is 1. But I'm always going to make a 1, so you could just say y minus b over 3.
But in the last thing, she said 7, but
Well, first she said 7, but then I said go further, it's y minus 7. It's always y minus whatever this divided by 3 is. So let me write it down. I'll say x becomes y minus 21 over 3. So this is the only number that matters for this first step. You take it, you divide by 3.
So the question when we're replacing it is 15x squared. So that becomes 15 times y minus 5 squared.
More than that, let's go now here. Let me go back to this now. So the question that we've been dealing with. So x is going to turn into y minus 5. It's not just this x, there's 3 x's.
No, I was just asking for clarification.
Yes. 15,
Okay.
yes. But this also, y minus 5 has to get cubed because the first x has to get changed to y minus 5.
I know that. I just was asking. Is that what that would be?
Yep. So this is looking like a mess, right? It looks like the question got harder. Now I want to remind you, I'm going to come over. So here we are at this point, and it looks desperate. It looks like, oh my God, why should I be happy? How is this any good? This is ugly. On the homework, there's a question
Can't you
that says,
combine all the terms?
we can't divide, unfortunately, because there's
I said combine.
combined, yes. So now let's go over the algebra for how to combine this stuff. So y minus 5, of course, that's just y minus 5. Y minus 5 squared is y minus 5 times y minus 5, which if you do FOIL becomes y squared minus 10y plus 25. And y minus 5 cubed is the same, is y minus 5 squared times another y minus 5, which is y squared minus 10y plus 25 times y minus 5. So now you're saying, oh no, this is really
What?
annoying. I took the answer I just got. I would take the answer I just got and multiply it by another y minus 5. And now you're saying, but that's so annoying. So good news for you. I promise I will give you on the.
Can you go back, please?
Oh, wait,
Like,
but
you
first,
jumping screens and this is really
I
confusing.
know, before I go back, I want to tell you that I want to show you the reference sheet so that you can not get nervous. Look at this. Look what I wrote here in the reference sheet. I'm giving you that. And the reason I'm showing you that now is because you probably don't want to multiply this out. Not that you can't multiply it out, but it's hard, or there's a lot of opportunities for careless errors. This one here is not too bad.
So what would this equal?
Well, that's what I'm going to tell you. But I'm going to show you how. Well, let me first I'll show you what you would do if you didn't want to use the formula. If you didn't want to use the formula, you would have to multiply everything on the left by y, and then everything on the left by -5. And that would be annoying. But with a formula from the reference table, it will save the day. This is going to be given to you. On the reference table, I'm going to write it like this. I'm going to change the way I will give you this on the final. So if it's x minus 5, it's x squared plus 2 times -5 times x plus -5 squared.
We were just using y.
Yeah. Oh yeah. You know what? Yeah. So call it. Why don't I call it y then? I think on the final I'll do that with a y. This is for squared. We already knew that answer. But here comes the other formula from the reference sheet, and I will give this to you. Y plus A cubed. This is going to be given to you. It's Y cubed plus 3A.
It's a negative in the problem, so how'd you jump to a positive?
Oh, if it's a negative, then A's negative. So if it's a plus, the formula has a plus. But if there's a minus, you know what I'll do on the final? I'll also give it to you with a minus. You know what? That you just gave me a really good idea. I'll give you a minus formula also. I'll give you both. So the formula is going to be Y cubed minus 3A Y squared plus 3A squared Y. This is given on the formula.
Okay, I don't need to see the formula. I need to see the problem that we're working in right now, which is which is Y minus 5 cubed.
Letitia, I think you do need the formula because now I turned the A into a 5. And without the formula, I think you'll have trouble continuing. So I just changed the A into a 5. So Letitia, tell me what to write now. Substituting the A for a 5, what does this look like? Everything else stays the same, all the Y's and everything.
Y cubed plus, oh no, it would be a negative 15 Y
Mhm.
squared
Yep.
plus 15.
Not 15 because there's a squared here.
I don't know. I don't know.
3 times 5 squared.
75.
That's right.
Y minus 5 cubed.
That's right. I will give you that formula on the final.
I'm confused at where.
Where are we in the problem?
Well, I couldn't reproduce this one more time.
Do you mean if
Like,
you
I'm
had the
confused
formula,
at-
if you had this formula given to you, you couldn't put the change the A's into 5s?
I guess I'm confused at how the formula is related to the question. Like, I don't
Yeah.
understand.
Well, let's go back to the question. Here we are.
Like,
This is where we were in the
the
question.
minus 450, 15, 36, those just disappear.
No. We now have to take that answer we just got. Y cubed minus 15Y squared plus 75Y.
So what happened?
Yep.
Wait a minute. Okay. What happens to the Y minus 5? Oh, Y minus 5 cubed is there.
I replaced the Y minus 5 cubed with that big monstrosity we just got. And I replaced the Y minus 5 squared with the less monstrous thing. Whoops, why?
Where you get 15 from? Oh, 15.
The 15 was part of the question. Now I'm not going to, well, I think I'll tell you eventually this thing simplifies. I'm just going to go dot, dot, dot. and it turns into I will, for those who want to stay after, I will go through the dot, but I want to let people go in a second. So I want to just,
Do we need to do the dot, dot, dot?
oh yeah, the dot, dot's just a bunch of adding and subtracting, but for right now, I'm going to show the dot, dot after I let everyone leave who wants to. And you'll notice this new equation, if I has no y squared in it anymore. It dropped out. It disappeared.
You have to walk me through this. I don't understand this
Yeah,
at
what
all.
disappeared?
It's
The y
not
squared.
making sense
In
to
this
me.
new equation, it just so happened. I didn't show the dot, but I'm going to after I let everyone go, and it will turn out every time that the y squared just will be gone. I'll demonstrate that in a second.
I understand how the y squared is going to cross out because when you do 15 times everything in the parentheses.
That's right. That's it. You're exactly right. You're exactly right. Good going, Letitia. You noticed that the 15 was going to get distributed through and cancel that with the other one. Very nice. Now this y cubed equals 39y plus 380. We actually just did that question. And we got 9.01. Remember? That was the question we did on the Desmos, except it had x instead of y. In other words, I had to use the Cardano formula to go from here to here. I just did the 39,380, right? That's what we just did. That's over the 39,380 was back over here. Remember this one? We got 9.01.
Not really. I would like to do another problem if we
Oh,
can.
right, but this was the one we did on Desmos. We just did it, but yes, we could do another one of those. But let me finish up so I can let people go. But anyone who wants to stay can stay. Where am I? Where am I? Where am I? Where's my? So y became 9.01. But the question was not what's y. That's the answer to this question. The question was what's x to the original. Does anyone know how you finish this up? There's a tiny 3-second thing, maybe 2 seconds for this. Let me get rid of that. That highlighting.
It would be 9.01 minus 5.
That's right. And that's the answer to the question. Letitia, you're really following along nicely. 9.01 minus 5 is 4.01. Because like that x is y minus 5. So you have to then take 5 away at the end to make up for that. Very, very nice, Letitia, to see the big picture. You just answered 2 very good questions. The first was how you explained why the y squared was going to cancel out. And then you look back at how y and x were related. Now everyone can leave who wants to, and anyone who wants to stay can stay. I'll explain missing steps, but I kind of went further than I don't want to keep you after. But this is the process of turning a cubic equation that has a x squared into a cubic equation that has no y squared in it, and then answering the no y squared equation with the formula we had just learned, and then using the answer to figure out what the x of the original 4.01 is the answer to this question. So go if you want, but anyone who wants to stay, I'll stick around.
I'm still trying to factor this out. Give
Do
me a minute, please.
Do you mean you're trying to do the dot, dots?
Yes, I am. I'm trying to do it on my own if I'm going to be responsible for it.
Good.
I have a question. Okay,
Yeah.
I just want to make sure I lost my train of thought. So once we get to the y cubed equals 39y plus 380, we're using Cardano's.
That's right. 380 divided by 2.
Okay.
380 over 2. 380 over 2 squared minus 39 over 3 cubed. And that big ugly answer.
Okay.
you could actually, on the final, you'd leave the big ugly answer. And your X answer would be the big ugly answer minus 5. Because I'm not going to make you.
I have that is X, but it's Y. Y equals the cube 190.
Yes, that's the Y value. But X is just Y minus 5. So you just throw a negative 5 at the end. You throw a minus 5 at the end.
Yeah, I think I need to do this again. I'm
Let me take a quick look at what the homework is to make sure. I think I have to remove some questions from the homework just because of the we didn't get to the Napier. So let me just come over here for a second. So on the homework, incidentally, I don't actually have you do a full question on the homework like this. I just have you stop. Here, let's take a look. Homework 13.
Okay, so I got to y cubed minus 39y minus 20 is equal to 0.
Wait, y cubed minus 39y minus 20 equals 0? Did
Yeah,
you say? Okay, there must be a slight error. Let me it's
because
not
it's
minus 20.
125,
Negative 125.
negative 125 plus 375 minus 180 minus 450.
Oh, that's the right thing. Maybe I made a mistake. It's negative 125 plus, you said 375?
Yep,
And then
because
minus
everything else is
180?
negatives. Yeah, everything else is negative. So you do,
Let me look at that.
oh, it's 380. Sorry, 380.
Can
380,
you walk us
yes.
through the
That's my
dot,
math.
dot?
Yeah. So what do you do after that?
After you get
It's
that,
plus 380 on both sides.
here, let me come to a new page for that. So here you were at this point, y cubed, what was
Minus
it?
39. Minus
39y.
39. Y. Minus 380.
Yes, add 39y to both sides and
Add
add
39.
380 to both sides.
Y.
Professor, I thought you were gonna walk
Plus
us through the dot, dot,
380.
dot.
Yeah, I'm gonna do that next. Let
Y
me,
cubed is equal to 39y plus 380.
and then comes the ugly formula.
Oh my God. So I have to go back to that cube formula,
That's right.
which we didn't. Oh, that was from that. Okay.
And now we just stick a minus 5 at the end and we call it a day. Let me make that minus 5 neater. This is how we leave our answer. I know I wrote 4.01 just so we could relate to it a little bit better. But this is what you write as your answer. You leave it just like this because we're not going to have Desmos on the final to calculate out that cube root
Oh, I
190
just leave it as that.
don't forget the minus 5 at the end. Just like when you did 9.01 minus 5, that big ugly thing
Okay,
is
so it would be x is equal to y minus 5,
and the y was that crazy thing.
which is equal to cube 190 plus 33903 plus cube
Now, of course, you get
190
the formula of the
minus
final.
squared 33903.
And
And
then,
that would be the final answer.
no, you got to put the plus minus 5 on. Remember when you took away 5 from the
Yeah, I did
9.01?
my, huh?
Remember Did you have the -5 at the end?
Oh. -5.
Now it's done. This would
Where
be
did you
full
get
credit.
-5 from?
Remember when you did 4.01?
Oh, because X is equal to X is equal to Y -5.
That's right. That big ugly thing was just Y. So you still need to throw the -5 at the end.
Okay.
Now there was a question about simplifying. So let's go through that. The point we were at was, if I have this right, we were at this point. It was Y.
Are you going back over what I just did?
Yeah. Y
Okay, so I'm
cubed.
gonna go.
Okay. -15y squared plus 75y minus 125 plus 15y squared minus 10y plus 25. What was next? Plus 36 y minus 5 minus 450. So who's with me still? Stephanie?
I'm watching, but I feel like I'm lost from the beginning. I feel like I couldn't reproduce what we just did.
Well, let's look at what the original question was. So since you're talking about the beginning, let's go back to the beginning. Step 1, replace y with, replace x with what?
Y minus 15 over 3.
That's right. And 15 over 3 is 5. So are you okay with step 1?
Yeah.
Step 2, literally replace each of these x's with y minus 5. So are you good on that step? Now expand this and this. Now to expand those, we have formulas that I gave you, and you'll tell me if this is a part that you're confused about. Okay, so are you okay with how I got to replace this with this? And I replaced this with that. Because we got to figure out what point do you get lost at. Now, I will be providing you with the formula for expanding the y minus 5 cubed, so you don't have to actually multiply it out.
Okay. Maybe that's what I got.
Let me go on the side. If on the final you're told this, and then at some point you're asked to do y minus 5 cubed, would you be able to finish the question, the expansion?
Yeah, I think so.
Okay. Now, this y cubed minus 15y, that we just copy. But the 15 I have to distribute through. So what happens there? I have to get rid of these parentheses. How do I do that?
Yeah, you multiply. So 15y squared minus 150y minus 25 times 15.
Yes. 2515 might be 375. I think it's plus. We also have to distribute the 36 through. Because see, there's this y minus 5 here. So what happens there?
36y minus 5 times 36.
That's right. Now, there's only one y cubed. Whoops. So that just ends up in the answer. This should have a squared on it. Now 50y squared gets combined with the negative 50y squared gets combined with the 15y squared.
Okay.
No other y squares in the whole thing. I'm just going to write just for instructional purposes. No y squares. Now there's also 5y minus 150y and 3y. What happens when you combine those?
$25, $28, 150 minus 28, 122.
Wait, it's negative 150y though.
Yeah, so minus negative 122.
The y that I'm sorry, this is 6y by accident. So you're saying 75 minus 150 plus 36?
No, where do you
What is-
see 75?
What did you
Yeah,
70
you
here?
just combine, yeah, you combine the greens. So what is that, 30? What is
Yeah.
that? Can't really read it. 30,
What's 75 minus 1?
is that 7? I thought that was 25. 75. Okay, so then
Oh,
minus 75 plus 36,
yeah,
negative 39.
yeah, negative 39y. And finally, oops, I lost my thing. There's a bunch of numbers, right? Also, here I'll try to I'll get my let me just get my this thing back up. Hold on. Um,
I guess it's easier for me to see on that one slide, the steps in order instead of like a bunch of different slides. So if you just post that, I guess I can use that. And you said there isn't a question?
what'd you
like
get for that?
I can't write it all down and I can't see your screen anymore. So I was just looking
Oh
at
well, okay. Let me share the screen again.
I'm
So that's what
trying to
happened.
write it all down, but it's like too much to write and like
Let's see. Share screen. Hold on.
if you just want to
Let's bring
finish
this
the
back up.
slide.
Well, what happens? There's still one more piece left, right? There's the numbers. There's the 120 negative 125, the 375, the minus 180, and the 450. What happens when you put all that together?
minus 200. Oh wait, I didn't do the 80. Negative 380.
That's right. Now, if you just move over the 39y and the 380, you get this. And that is the other kind. The first type we did. Remember we had that formula with the, it's kind of a crazy formula?
What, with the cube root?
Yeah.
Yeah.
So y became this kind of ugly thing with the cube roots.
Oh, so then we go back and do what the x 39 over, wait, 380 over 2 squared,
Yes.
and then 3,
Here you go.
39 over 3 squared, 3 cubed.
Cubed for that one, yeah.
Okay.
So that ends up becoming 190 here and here. And 33903 here and there. But we're not done, but we're almost done. Because the question originally
We have to put the
was
minus 5.
they wanted to know about X. Yeah, so how do we finish it up?
I don't remember where, but there was a minus y minus x equals y minus 5 somewhere.
Yeah, it was the very first thing we did.
Yeah.
We replaced X with Y minus 5.
So you just stick minus 5 on the end.
And we leave it like that.
Okay.
Now, if we were to type this whole mess into a calculator, it would be about 4.01. Just if you say, well, I want to know what the answer is, like not this ugly thing. Now, you'll see on the homework, I actually didn't make a question that had you go all the way through. Let's see. We're not going to do questions. Wait a second. Where's the Cardano? Yeah, we're not going to do questions 4, 5. We're not going to do 3, 4, 5, and 6. Let me move those. There we go. So let's take a look at the homework, just so you can get a sense of what we did today and what's on the homework. So there's this chord question where I tell you chord 40 and ask you for chord 140. There's the completing the square process. See this? Number 7. How do you feel about that question?
If we have to go as far, we just have to come up with the cube root from that? The cube root plus,
Yes.
if they're both cubes in the formula?
Yeah.
Okay.
And then look at this for see for number 8, I'm just having you practice expanding. And number 9, I'm just having you practice expanding. I feel like I should change this so that it's not the same exact question.
So y minus a to expand, use the formula to expand the expression. So what,
We're just, see, number 8, 9, 10 are just like practicing the skills, the algebra. And then 11 is where I ask you to change the equation into the y equation, but not to solve it, just to leave it. So it says don't solve the new equation though.
yeah, I don't know. I'm gonna have a lot of trouble with this. I feel like it's better for me to just wait for the solution and study the solution than to try to do it and get confused.
Yeah, which you know,
Like I
number
don't like expand, use the formula, like expand,
number 8,
that's the first step to expanding it.
number 8.
Yeah, sure.
You literally turn the 3 A's into the number 4.
And leave
There's only
Y.
one step.
Okay.
Turn all the A's into, because this is a formula for how to do y plus a cubed. And then they're asking y plus 4 cubed. The only difference between the formula and the question is that there's a 4 instead of an a. So what is the answer for number 8?
Y cubed plus 12 y squared
Uh-huh. Plus.
plus 12 squared y.
Except you have to do 4 squared times 3. Instead, you have to do 4 squared and then times 3. Don't do 3 times 4 first. 3 times 4
3 times
squared,
16
16. Yeah, 3 times 16, right?
plus 4 cubed.
Yeah, that's what I'm asking you to do in question 8.
So if you put in if y minus, so we just put the 6 there.
That's right. Oh, I realize question 10 and 11 are maybe a little harder than I meant them to be. Sorry. Number 10. These minuses might throw people for a loop. These 2 minuses might make it a little bit harder. I'll be curious to see what people do.
Did you say that you were gonna give us on the final though a different one with the minuses?
Yes. So currently on the final, the reference sheet only has the current reference sheet. I don't like what that has. It has where is it? The current reference sheet just has this, but I'm going to change that. So it's x plus a, x minus a squared, x, I'll say, I'm going to change it to y plus a squared, y minus a squared, y plus a cubed, and y minus a cubed. I'm gonna add more formulas.
Okay. All right.
Okay, I think you'll see. I think you'll see that with practice, this won't be too bad. Especially, you'll have the formula. The only thing you have to kind of memorize is the y minus b over 3a thing. A is always 1, so it's it's just b over 3.
Okay.
Okay, so
All
I'll
right,
see you
thank
tomorrow.
you. Okay.
Okay, bye.